In the previous video, we introduced the general multiplication algorithm for converting from any number base to decimal. Now let's look at how we can apply that to a specific case of converting from octal to decimal. So the formula is this: given a number in base 8, so an octal number. Let's just say our number is WX, Y, Z. These are the digits of our octal number. This example is going to be a 4-digit number, but this will work for any number of digits, any size of octal number. So the first thing we want to do is we're going to write out our number with placeholder subscripts. And what do I mean by that? So if these are the digits of our octal number, a subscript is going to be a number just right at the foot of each of these digits, and we're going to start at 0, and we're going to get bigger as we move to the left. Great, so then our step 2 is we're going to multiply each digit, so the Z, Y, X, and the W, by 8 raised to whatever subscript is on that digit. So it looks like this. Here's our general number. Here are our subscripts. I'm going to take the digit. The digit is Z, and I'm going to multiply by 8 raised to the 0 because 0 is the subscript on Z. I'm going to do this for the next number, Y times 8 to the first, and then this one is X times 8 to the second because 2 is a subscript on X, and then the W digit I multiply by 8 to the third. Then step number 3, to get the results of the conversion, the result is the sum of all of these products. So whatever that is, whatever that is, whatever that is, whatever that is, we just add all these up, the sum of the products. Okay, and that's it. So let's see a couple examples. Let's see a small easy one and a larger, more complicated one. So example 1, let's convert octal 74 to decimal. Alright, so the first step, we write out 74, we put our placeholder subscripts, and then we take the digit, this is 4, and we multiply it by 8 to the 0. Then we take 7, and we multiply that by 8 to the first, because 1 is a subscript on the 7. Okay, and the reason why this is an 8 is because we're going from octal to decimal. Anything raised to the 0 power is 1, so this is just going to be 4. 7 times 8 is 56. So to get the result of our conversion, we just add all these products up and we get 60. Therefore, 74 in octal, so base 8, is equal to 60 in base 10, and that's how we do the conversion. Let's look at a second example. Example 2, what if we convert octal 3704 to decimal? Okay, so we follow the same steps. We write out our number. This is our octal number. We put in our placeholder subscript 0, 1, 2, 3, and then we take each digit. So the first digit's 4. We multiply by 8 raised to the subscript on 4, which is 0. The next digit is 0. We multiply by 8 raised to the subscript on 0, which is 1. And then we take 7 multiply by 8 raised to the subscript on 7, which is 2. And then finally we take 3, multiply by 8 raised to the 3rd, because that's a subscript on the 3. Okay, so this is going to give us 4. This is 0, because multiplying by 0. Whatever this turns out to be is going to make no contribution to our final number. 7 times 8 squared is 448, and 3 times 8 to the 3rd is 1536. Okay, so to get the result of our conversion, I'm just going to add up all these products. So you just add straight down, and we get 1,988. Therefore, 3,704 in octal is equal to 1,988 in decimal.